Hello and welcome students. In the last video lecture, I had started chapter 2 of statistics, that is linear correlation, in which I had explained you the meaning and definition of correlation, meaning of linear correlation, types of correlation and methods of correlation, in which we had studied the first method of correlation, that is scatter diagram method. In this video lecture, I am going to start the second method of correlation, that is Karl Pearson's method. The name itself suggests that this method was suggested by one of the statisticians, that is Karl Pearson. So according to his name, this method is given the name, that is Karl Pearson's method. Now the correlation coefficient is denoted by the letter, that is R. So every time wherever there is correlation coefficient, will not write word correlation coefficient, but will denote by the letter R. Now the first formula to find the correlation coefficient by Karl Pearson's method, that is R is equal to covariance. It is pronounced as covariance of xy upon standard deviation of x into standard deviation of y. Students, in standard 11th you have studied standard deviation, that topic. So over here it is very easy for you, that is standard deviation of x into standard deviation of y. This is the basic formula that you have to remember, that is covariance of xy upon standard deviation of x into standard deviation of y. Now how to find covariance of xy? The formula of covariance of xy is equal to sigma. Sigma means total sum. Sigma x minus x bar y minus y bar upon n. Now x bar you are knowing how to find. X bar means mean. Already we have studied in standard 11, that is measures of central tendency, mean, median and mode. In that, x bar we used to find out by sigma x upon n. X value was given to us and we are doing the total of it and dividing by the number of observation. In a similar way we used to find y bar. So x bar and y bar, that is sigma x upon n and sigma y upon n. So the formula for covariance of xy is equal to sigma x minus x bar y minus y bar upon n. N means number of observation. Now how to find standard deviation of x? Standard deviation of x is equal to under root of sigma x minus x bar whole square. X minus x bar whole square upon n. In the similar way, to find standard deviation of y, under root of sigma y minus y bar whole square upon n. So basically we have studied three formulas to find the value of r, that is covariance of xy, standard deviation of x and standard deviation of y. By substituting all these three formulas in the basic formula of r, we will get this formula, that is r is equal to, see what is r over here? Covariance of xy. Now what is the formula of covariance of xy? That is sigma x minus x bar y minus y bar upon n. So instead of covariance of xy, I am writing over here, that is sigma x minus x bar y minus y bar. Now standard deviation of x. What is the basic formula? Covariance of xy upon standard deviation of x. So instead of standard deviation of x, I will write sigma x minus x bar whole square. So over here under root of sigma x minus x bar whole square. And in place of standard deviation of y, I will write sigma y minus y bar whole square. So into sigma y minus y bar whole square. So from this n and n will be cancelled. Over here also there is in denominator n and over here also in denominator, that is n. So it will be cancelled. So the new formula of r, that is we have to utilize the practical sums, that is r is equal to sigma x minus x bar y minus y bar upon under root of sigma x minus x bar whole square into sigma y minus y bar whole square. This is the main formula that we have to apply in the practical sums while finding correlation coefficient by Karl Pearson's method. Now when this formula will be utilized? This formula is used when both x bar and y bar are integers. It means you have to find out over here x bar and y bar. When x bar and y bar will be coming in integers, not in fraction. Integers means suppose value of x bar comes 10 or when value of y bar comes 12, then this formula we have to apply. But suppose the value of x bar and y bar comes in point, that is in decimal or fractions, that is suppose it comes 10.35 or 10.50, then the another formula we have to apply over here, this formula will not be applied. This formula will be applied only in the situation when the value of x bar and y bar are integers. Now moving on to the next alternative formulas that we have to study over here. First formula over here, that is covariance of xy. The basic formula of covariance of xy, that is sigma x minus x bar y minus y bar upon n. But alternative formula, when the other values are given of covariance of xy, that is when the value of sigma xy is given to you in the question, when n is given, x bar and y bar are given to you in the question, then the alternative formula to find covariance of xy is sigma xy minus n x bar y bar upon n. Now it depends upon the sum, in which sum we have to utilize which formula. Depends upon the data that is given in the formula. If the values of sigma xy, x bar, y bar and n is given to you, then you have to apply this formula to find covariance of xy. The other alternative formula for standard deviation of x and standard deviation of y, which you already studied in standard 11, that is under root of sigma x square upon n minus x bar whole square. You can also write sigma x upon n whole square. We can write over here, that is sigma x square upon n minus sigma x upon n whole square in under root. It means in the same way we can find, that is standard deviation of y, that is under root of sigma y square upon n minus y bar whole square or sigma y upon n whole square. These two formulas you are very much familiar in standard 11, that we already studied of standard deviation of x and standard deviation of y. Now we should understand other formulas to find correlation coefficient. The first one, that is r is equal to sigma x minus x bar y minus y bar upon n into sx into sy. Sx matlab standard deviation of x into standard deviation of y. Now when this formula is to be utilized, when in the question the sigma x minus x bar, y minus y bar is given to you, value of standard deviation of x, value of standard deviation of y and n is given to you. In the following situations, we can utilize the formula of r, that is sigma x minus x bar, y minus y bar upon n into sx into sy. Now the next formula of r, that is sigma xy minus n x bar y bar upon n into sx into sy. Now when this formula is to be utilized, when the data related to this formula is given in the question, then we can utilize the another alternative formula of r, that is sigma xy minus n x bar y bar upon n into sx into sy. When in the question the data of sigma xy, value of xy, sigma xy, x bar, y bar, n and standard deviation of x and standard deviation of y is given to you in the question, in that situation r is to be found out by applying this formula. Now the main important formula over here, that is second important formula, we have already studied when the value of x bar and y bar are integers, then in that case we have to apply the formula, that is sigma x minus x bar y minus y bar upon under root of sigma x minus x bar whole square into under root of sigma y minus y bar whole square. Now if the value of x bar and y bar, either of that two or both, are fractional, then we have to apply this formula that is highlighted over here, that is r is equal to n sigma xy minus sigma x into sigma y upon under root of n sigma x square minus sigma x whole square into under root of n sigma y square minus sigma y whole square. This formula will be used when mean means that is x bar or y bar, or both, means either they both are in fraction or any one of them is in fraction, then the above formula is to be utilized. So the two main important formulas that we have studied till now, that is when the value of x bar and y bar is integer, then we have to apply the formula, that is sigma x minus x bar y minus y bar upon under root of sigma x minus x bar whole square into under root of sigma y minus y bar whole square. And when the value of mean, that is x bar and y bar, is fractional or any one of them is fractional, fractional means either it is coming in point, that is 10.2, 10.5, 11.3 and so on, then we have to apply the formula that is given over here on the board. Now, the next important topic that we are going to study, that is properties of R. That is properties of correlation coefficient. Students, this chapter carries weightage of 12 marks. If you are having your textbook, then you can see there are 4 chapters in statistics in the first part, and all are having equal weightage, that is of 12 marks. So you cannot neglect any of the chapter. The properties of correlation coefficient, this theory topic I have taken purposely because generally this question is asked in 3 marks in theory part in your board exam paper. So let us understand it. The first property of correlation coefficient, that is the value of R lies between -1 to 1. That is -1 less than or equal to R less than or equal to 1. Students, when you are doing the practical sums, if your answer comes 1.05 or -1.03 or 1.10, then you must understand that your answer is wrong, because never the value of R will come more than 1 or more than -1. So if your value comes more than 1 or more than -1, then somewhere you have done a mistake in the calculation. So this is the first characteristic or first property of R, that the value of R will always be between -1 to 1. Now the next property, that is it is free from unit of measurement. The unit of measurement means if the variable x and y may be having any unit of measurement, but the value of R which you will get at the end of the answer, you don't have to write any of the unit of measurement. That is, if the answer comes 0.58, then you don't have to write 0.58 kg. Even though the value of variable x and y is given to you in kg, the answer of R is free from unit of measurement. It means no any unit you have to apply in the value of R. Now the third point or the third property, that is the correlation coefficient is same between x and y as the one between y and x. It means the relation between the two variables, that is x and y, is equal to y and x. Means they are having interrelation between the two variables. The fourth property over here, that is it does not change with the change of origin and scale. Now the last point of property of correlation coefficient, that is R minus xy is equal to minus rxy. R x minus y is equal to minus rxy. It means if the value of any of the two variables, see the first one, the value of variable x is negative, and the second one, value of variable y is in negative. In both the situations, the correlation coefficient, that is R, will be negative. It means the sign changes of any of the variable, then it will change the sign of the correlation coefficient also. And if the sign of both the variable changes, it means over here see x and y both are negative. If the sign of both the variable changes, then no any change would be there in the sign of correlation coefficient. It will be as it is, that is positive. So up till now we have understood the formulas of correlation coefficient and properties of correlation coefficient. Now in the next video lecture we are going to understand the practical sums related to Pearson's method.